Assalamualaikum warahmatullahi ta'ala wabarakatuh, and very good day to all my students. This time we will learn how to solve the problem related to the second law of thermodynamics, specifically for heat engine. This is the sample of the question related to the second law of thermodynamics for the heat engine. A steam power plant receives heat from a furnace at a rate of 280 gigajoule per hour. Heat losses to the surrounding air from steam as it passes through the pipes and other components are estimated to be 8 gigajoule per hour. If the waste heat is transferred to the cooling water at a rate of 145 gigajoule per hour, determine A, the net power output, and B, the thermal efficiency of this power plant. This is the recommended step of solution to solve the problem. Firstly, identify the case are either heat engine, heat pump, or refrigerator, because each case have their own dedicated equation of formulation, which is need to be identified correctly. Secondly, sketch and extract the data from the question. In this case is heat engine. Third step, calculate net power output to obtain answer for question A. And finally, apply thermal efficiency equation based on the available data to answer the question B by using the equation of thermal efficiency equal to the work net out divided by the QH. Step 1. Identify the case either heat engine, heat pump, or refrigerator. Based on this question, several keywords or hint has been highlighted to identify the case of heat engine or heat pump or refrigerator. Firstly, steam power plant is the plant that produces power or heat from furnace and losses to the surrounding refer to the source and sink respectively. And we also can refer from the question net power output for the steam power plant, because for the heat pump or refrigerator, they do not produce the net power output, but they supply the power or work to the system. And the last keyword or the last hint is the thermal efficiency. Of course, for the steam power plant or the heat engine, obtain thermal efficiency, while for the heat pump and the refrigerator, they denote the efficiency in the form of the COP or coefficient of performance. So that, based on this question, we can conclude all this information related to the case of the heat engine, and we will try to solve all the question or information based on the heat engine equation or formulation. Step 2. Sketch and extract the data of heat engine. This is the schematic of the steam power plant, which consists of pump, boiler, turbine, and condenser. The turbine will produce the work out. We can simplify the diagram by having this kind of sketches, which refer to the energy source, to the source, and all major component of the steam power plant will be simplified on this small circle, which is denoted as a HE or heat engine. Heat engine. And then the energy sink, to the energy sink as well from the diagram. And we can also simplify the next step of the diagram by having this kind of sketches based on the question, which is source refer to the furnace, sink, same as well, sink, heat engine, and the work net out. And also, don't forget to provide all the information from the question. For example, 280 gigajoule per hour for the source, and 8 gigajoule per hour, and 145 gigajoule per hour for the sink. Step 3, calculate net power output. Total heat rejected by the power plant is 8 plus 145 equal to the 153 gigajoule per hour, and we remark it at the area of QL. And then the net power output, since we have this QH and the QL, we minus or subtract the QH to 80 gigajoule per hour minus 153 gigajoule per hour, and we obtain 127 gigajoule per hour for the work net out. And we convert from the gigajoule per hour in the form of the watt, and we found that the final answer is 35.3 megawatt. Step 4, apply thermal efficiency equation based on available data. Since we have QH, we have the work net out value as well as the QL value, so it's quite easy to determine the thermal efficiency equation. In this case, we using the work net out divided by the QH to 80 gigajoule per hour to obtain the thermal efficiency. So gigajoule per hour, cancel off the unit, and finally we obtain the efficiency 45.3%. Do not forget the simplification or the assumption for solve this problem. The plants operate steadily. This is the question, exactly the same with the previous one. It's just the matter of the changing some of the parameter related to the heat engine. So sir hope you can try to do this question. Sir also provide the final answer for each question for net power output and also for the thermal efficiency. Thank you and all the best. Assalamualaikum warahmatullahi taala wabarakatuh.